Okay, so today's lesson is the square root function. This is chapter 10.1 in your textbook. The square root function is represented by the parent function f of x equals the square root of x. So I came up with a table here on the left-hand side, and we're going to substitute all of these x values into that function. So first is 0. If I substitute that in, the square root of 0 is 0. Okay, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And the square root of 16 is 4. So if you notice, I chose x values that represent perfect squares. Okay, that way I don't have any decimals or anything like that. Now, if we were to take all of these x and y values and we were to put them on a graph, the graph would look something like this. So you notice it starts at 0, 0, and it curves upwards towards the right. It kind of looks like half of a parabola tipped over on its side. Okay, if we talk about domain and range first, domain is how far left and how far right does our graph go on the x-axis. So if we're talking about the left side, it starts at 0. There are no values to the left of 0. So 0 would be my left point. If I look on the right, I see an arrow that points to the right. That tells me that it's going to go off until infinity. So it's going to go from 0 to infinity. So another way of saying that is that the domain is all x values that are greater than or equal to 0. Range is the y-axis, so we're looking up and down. So my lowest point is 0. It doesn't go anywhere below that. But then my arrow points up and to the right forever, so it's going to go from 0 to infinity also. But this time we're talking about the y-axis. So y is greater than or equal to 0. Okay. These ones only go off in one direction. It does not point in both directions. That's just the way the square root functions work. Okay. The x-intercept, where does it touch the x-axis? Well, it touches at 0, 0. And our y-intercept is also at 0, 0. Okay, so we have the same x and y-intercept in this one. They both intersect the axis at the same point. Okay, so this is a try it. What I recommend doing is using the Desmos app so that you could graph both of these and tell me the domain, the range, the x-intercept, and the y-intercept. So remember, the website is desmos.com/calculator. Okay, go ahead and give them a shot and then come back and check your answers. All right, so hopefully you've used the Desmos app and you've graphed both of these. If you are looking at the first one, if we have a grid that looks something like this, a coordinate plane, our graph, I'm actually going to draw both coordinate planes so we have those. Just a little sketch to kind of give you an idea. Sorry, it's not the greatest. If we were to sketch what that one looks like when you have negative square root of x, you'll notice it starts at 0, 0, and it goes down, whoops, in this direction here. Something like that. Okay, so our domain, our left and right, there are no values to the left of 0, so x is greater than or equal to 0, and it keeps on going off until infinity. Our range is a little bit different this time because our minimum, it keeps on going down forever. So our minimum is negative infinity and it goes up to 0. So we can say all of our y values are less than or equal to 0. Okay, all values in blue would be less than that. Okay, and then just like the other one, our x and y intercept are at the same point. Both of these are at 0, 0. Okay, for the second one, if you were to graph this, the square root of x over 10, you get something that looks very similar to what our first one was. It starts at 0, 0, and it's kind of close to the x. It's a little bit thinner. So our domain is x is greater than or equal to 0. our range is y is greater than or equal to 0 because it's above the axis. And again, our x and our y intercepts are both at 0, 0. We haven't done a whole bunch of transformations here, so that's why the domain, the range, and the intercepts all look very similar to the parent function. And we're going to talk about transformations in a couple minutes. Actually, let's talk about them now. So transformations of square root functions. We have our parent function here at the top. Transformations are just like when we did transformations of other functions. We've done transformations of linear functions, of quadratics. It's the same thing. So if I want to move this up 2 units, all I have to do is add 2 to the end of my function. So I can say f of x equals the square root of x plus 2. So notice how the plus 2 is at the end. It's outside of the radical. That's going to shift everything up 2 units. So if I wanted to go down 3, I would do the same thing, but instead of going up and adding, I'm going to go down and subtract. And I'm going to subtract 3 because I wanted to go down 3. Left and right are the tricky ones. So first of all, in order to move left and right, that's on the x-axis, our number has to be close to where x is. It has to be touching x. And remember, from our other functions, left and right, it's the opposite of what you think it is. So normally when you move left, you feel that you're moving in the negative direction, but really you have to add to move left. So in this case, I would write f of x equals the square root of x plus 1 inside the radical. So see how it's not at the end, it's underneath the radical symbol, touching the x. So right 6 would be subtracting. F of x equals the square root of x minus 6. Okay, so left and right are inside the radical, up and down are at the end. And then we saw the reflection over the x-axis in our last example. So when we had quadratics and linear functions, to reflect them over the x-axis, we have to make them negative. So the negative square root of x. Now you could also have other transformations such as compressions and expansions or stretches that would be putting numbers in front of our square root, but for this lesson, none of our examples have compressions and expansions. Okay, so in this one, to try it, I've kind of given you the answers here. But if you notice that we have the minus 4 at the end of our first one, so that is why it is down 4. And then for B, the minus 10 is inside, so that's controls left and right. And because it's a negative there, a minus sign in between, it's going to be right 10. So like I said, very similar to when we did our other functions. Okay, so this is a very, very big one, rate of change for square root functions. So we've done rate of change with all different kinds of functions, with quadratics, with linears, it's all the same, okay? So they give us the function, the square root of x, okay? F of x equals square root of x, and we wanna see how does the average rate of change from 0 to 0.3, and then 0.3 to 0.6, so 3/10 and 6/10. Let's do one piece at a time. So what I'm going to do is I'm going to substitute these values into that square root function. So my first one says x equals 0, so I'm going to say the square root of 0, and I know that's 0. Okay? And then if I do the square root of 0.3, if I type that in my calculator, I'm going to have to round a little bit. I end up getting 0.548. Or 548 hundredths. Sorry, thousands. So those are my two values. Now, if you remember from when we talked about rate of change before, let me grab a different color here. Our equation is y2 minus y1 over x2 minus x1. We're still going to use that concept for this one. Oops, let me go back. Okay, so our x value was 0, and our y value, our answer, came out to be 0. So that's our first ordered pair. Okay, and the second one, our x value that we put in was 3/10. And the y value that we got out was 0.548. Okay, so now if I substitute those into this equation, y2 minus y1, well, I have x1, y1, x2, y2. So my y2 value would be 0.548 minus my y1 value is 0. My x2 value is 3/10. And my x1 value is 0. So if I go ahead and do that subtraction there, I end up with 0.548 over 3/10. And if you divide that, you end up getting 1.83. Okay, so that is the rate of change of this function between the x values of 0 and 3/10. Okay, so now we have to do the same thing with the other one. We already know 3/10. We know the square root of 3/10 is 0.548 because we already found that from before. Now we have to do the square root of 6/10. Okay, the square root of 6/10 is 0.775. Okay, and we're going to do the same thing. So our x values, let's write them as ordered pairs. The x value we put in was 3/10, and we got 0.548 out. The x value we put into this one was 6/10, and we got 0.775 out. So if we substitute those into the equation for rate of change, I would take my x1, y1, x2, y2. I would have 0.775 minus 0.548. It's a 5 there. Over 6/10 minus 3/10. Okay, when we do that subtraction, we end up with the top is 0.227. And our denominator is 3/10. So overall, when you divide that out, you should get 0.757. All right, so now we have to compare the two numbers that we circled. So I have 1.83 on the left and 0.757 on the right. And we want to compare these so we can say the rate of change between 0 and 3/10 is greater than the rate of change between 3/10 and 6/10. Okay, so you can either write it as an inequality or you can write that in words. Okay, here's a try it. So I recommend giving it a shot. They're asking you to find the values of each of 8, 10, and 12 because you're going to need those for both A and B. So go ahead and pause the video, give this one a shot, and then come back and check your answers. All right, so let's see. I have the function h of x equals 2x, or the square root of 2x. So I need to substitute 8, 10, and 12 in each one of those. Okay, so if I do the square root of 2 times 8, I need to do the square root of, sorry about that, 2 times 10, and then I also need to do the square root of 2 times 12. So I'm going to need these values in a couple of minutes. All right, well, 2 times 8 is 16. So the square root of 16, I know, is 4. All right, if I do the square root of 2 times 10, well, 2 times 10 is 20. That is not a perfect square, so I know I'm going to get a decimal. I get 4.47. And then for the square root of 2 times 12, well, 2 times 12 is 24. Again, not a perfect square, but I get 4.9. Okay, let's use these values here to figure out. So for part A, they want to know between 8 and 10. So when x is between 8 and 10, what is the rate of change? So I'm going to write ordered pairs. I know my first ordered pair is going to be 8. And when I substituted 8 into the problem, I got 4 as my y value. So that was my x1 and my y1. And then I plug in 10 into my equation, and I got 4.47 as my y value. Okay, so that's my x2 and my y2. Again, I'm taking those from the x values we put into the equation and the y value we got out. So now let's go ahead and plug it into the equation for rate of change. So as a reminder, that is y2 minus y1 over x2 minus x1. So in this case, we have 4.47 minus 4 over 10 minus 8. So you should end up with 0.47 or 47 hundredths, and 10 minus 8 is 2. So our average rate of change it comes out as decimal 0.235. All right. For part B, they want us to find between 10 and 12. So when I substituted 10 into my equation, I got 4.47 out. When I substituted 12 in, I got 4.9 out. And again, if I do my x1, y1, x2, y2, I'm not going to write that. But if I put in the equation, I'm going to have 4.9 minus 4.47 over 12 minus 10. So 4.9 minus 4.47 is 0.43. And 12 minus 10 is 2. So when I go ahead and I divide that out, I get 0.215. And then this one did not have us compare them. It just had us find the average rate of change. But obviously, the rate of change for this function is greater between 8 and 10 than it is from 10 to 12. Okay, don't forget to use our rate of change equation for each one of these. Okay, there is an example I'm going to skip it. It's just a real life example of when you would use these. It's simply evaluating the different ones. So you're substituting in the value that they ask for and then comparing the two. You can look at that one in your textbook. It does give you the answers there. The classwork for this section is page 415, numbers 3 through 11. And the exit ticket is page 416, 15A and B. Please make sure that you are submitting the exit ticket to me. You can do that via Schoology. You can drop it to me on the drive or email it to me, whatever is easiest for you. If you would like me to check the classwork before you submit your exit ticket, I would be happy to look at that for you. And I'm also available on Blackboard Collaborate. The link to my Blackboard Collaborate sessions is in the foot of my email, so you can just click on that link.